This is the final acceptance review presentation video for Team 19025. I'm Brian Boyler, and Julia will be helping me present this presentation. Our other team members are Mustafa, Sabrina, and Parker.
Roche Tissue Diagnostics needed a solution for a hands-free login for their medical instruments. Our group was assigned to create a facial recognition program that can allow lab technicians to log into the instruments without using their hands. These are the functional requirements that were provided by our sponsor, Roche, initially. Throughout the semester, we have used and built upon these requirements as a foundation to our system. As our project is now done, all of these requirements have been verified and completed. The listed use cases were developed to provide an understanding of how our software will operate in the intended environment. The first use case shows that the system will log in the closest user to the camera. The second use case shows that the system will display an error notification if a user is unable to be authenticated by the system. The third use case shows the functionality of adding a user. The fourth use case shows that when a registered user can't log in with the facial recognition system, that they will have the option to log in manually.
Our system was designed to operate in a Roche lab environment. The camera in our system is intended to be mounted on a medical instrument. Frames from the video feed provide an input to the system to log a person in. The design boundaries are confined to the user input. Derived from the needs of our sponsor, we have our system requirements. There are 6 categories of system requirements: interface, environmental, customer, performance, user, and security. Our authentication algorithm works by taking frames from a live video feed, extracting the facial attributes, and comparing those attributes to the ones in the database profiles. Upon authentication, a confirmation message is displayed, and then the person is directed to either the admin or user page. The admin allows an admin user to modify or delete a person in the database. As far as our authentication performance, we came to the conclusion that our program would authenticate a user if a 90% confidence in the face match is reached. We wanted the time to authenticate a user to be less than 3 seconds. The user requirements cover the basic functionalities of the admin user interface page. In order to make our system a truly hands-free login, we implemented a microphone wake-up algorithm that allows the user to start running the program when they say the keyword wake up. Overall, each one of our system requirements serves a purpose of fulfilling the needs developed in the ConOps. At this point in time, our team is able to deliver a completed product which allows users to use facial recognition to authenticate permissions into a protected system. The 4 subsystems that make up our system are the user interface, camera, facial recognition API, and database. The combination and integration of these 4 allow our lab technicians and administrators to authenticate using a hands-free microphone wake-up and facial recognition. The database integration allows user profiles to be created, deleted, and modified based on the company needs. Throughout this project, we had 3 different design iterations. When our project started, we derived all the system requirements that we thought we needed. During each iteration, we chose some of these requirements to complete and verify. Requirements were prioritized based on the time to complete them and the ones that were the most important to our underlying functionality. For our first iteration, we chose 6 requirements that we thought were the most important to the foundation of the system. The next iteration, ISR, we select the requirements that were a vital part of establishing and accessing a cloud database. Finally, we just completed the last iteration, which was focused on completing the remaining requirements.
As we prioritized iterations, we used Jira as our project management tool to manage tests through the project iterations. The graph below illustrates the cumulative issue status over time since we started in late September. This helped us as a team to detect bottlenecks so our progress can continue efficiently. The following documents encapsulate the entire project delivery and will be delivered to our sponsor. The main hardware component of our system was the camera. A trait study was conducted to select the camera that was best for our system. The trait study focused on the performance of the camera and coupled with software development kit, schedule, and cost. Based on the trait study's results, the team chose to use the Microsoft Azure Connect DK. During the design process, the team faced the issue of unable to awake the system using a hands-free method. The risk was mitigated using a microphone wake-up after conducting the following trait study. This trait study prioritized a hands-free interaction and reliability above all. Our team used Agile methodology while developing our software. This began with determining the system requirements that would be included in our minimal viable product, highlighted in yellow in the table. And this provides the basic functionality of the system. The next set of requirements focused on failure cases and user profile manipulation, highlighted in green. Finally, the rest of the requirements focus primarily on improving the performance of the system, highlighted in red. Each system requirement was performed based on the documented test procedures. Zoom meetings were conducted which allow a software developer to present the functionality of features that needed to be verified via tests to the system engineers. Inspections were made to verify features which primarily ran in the back end of the system that allow other functions to take place. Analysis were conducted to verify features when a repetition of tests were needed to prove functionality, or in the case of cost, when the cost needed to be calculated to ensure budget was met. All customer constraints, performance requirements, user requirements, and security requirements were verified successfully. In the following section, we will show a demo video of our system. First, the user interface will prompt the user to say wake up in order to start the system.
Wake up.
As soon as the camera wake up, it will start the live video feed and recognize faces. If registered as an admin, the administrator's page will show up with the list of registered users. Without selecting a user and click Modify button or selected a user but nothing has typed in the text boxes, an error message will show in the bill. If the user type in any of the text boxes and then click the Modify button, then the changes will be made immediately and show in the users list. The system will not allow the user to delete whoever is currently logged in. It will also make sure that the database at least has one user. The Create New User button will allow the administrator to create new users. All the fields are required to fill out before the system starts collecting faces. The system will take 25 pictures to ensure enough data points are collected. The status will show as increasing numbers while the pictures are being taken. When it's done, a successful message shows up and prompts the user to take further steps. If click on Cancel button, the user will not be added and will not show on the user list. Now we click on the Create New User button again and redo all the steps to create a new user. But this time, we click on the Save button when it is done collecting the faces. Now the new user with name Hello is added successfully to the system and shows up in the users list. And when the Logout button is clicked, the user will be logged out of the system and be redirected to the startup page.
Wake up.
If somehow the user needs an alternative way to log into the system, the user can click on the Manual Login button. We try with the normal user which is created, and the system will redirect the user to the normal user's page. And if we click on Logout again, the system will log out the user and take us back to the facial recognition page.
As you can see from the table, all interface requirements have passed the verification procedure. Again, this table shows that each environmental, customer, and performance requirement have passed the verification procedures. Lastly, this table shows that all user requirements have completed the verification procedures. More information pertaining to the verification of our system requirements can be found in the acceptance test procedure document.
During this year-long course, we were exposed to how the real-world engineers collaborated with others with different backgrounds. We also learned how the design process would be like if implementing Agile methodology, as well as communicating with customers and adapt to their needs as working toward the project. We're delivering the system on April 25th. The code will be uploaded in our private GitHub and transferred to the sponsor. We plan to mail the camera to the sponsor by May 13th.
In conclusion, we have completed the final product that meets the original needs outlined in the concept of operations, and each requirement of our system has been verified. Lastly, our sponsor will receive the final deliverable by May 13th. Last but not least, we want to thank our sponsor and our mentor for all the help they have provided us. We have learned a lot this year, and I don't think we could have completed this project without you guys. Thank you again.